ever need anything.
Oh,
I don't know. I don't know what I need, but I'll keep the car.
All right, I'll call to order this meeting of Sumner County Board of Construction Appeals for April 16th, 2025. Would you like to ask our blessing? Terry?
Yes. Father, we thank you for this beautiful day. We thank you for the fellowship we share and all the blessings we have day to day. And help us to understand the holiness of this time that we're having right now at Good Friday, the resurrection, and help lead us to your glory. And we pray all of this through your Son and our Savior, Jesus Christ. Amen.
Amen. Jim, you want to lead us in the pledge?
Okay.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I almost had a cough there at the end.
Todd, do you want to do the roll call, or?
Yes,
you wanna
sir.
have your- Okay,
I see Barry Briley, Roger Smith,
here.
Bruce Quinn, Brian Lynch, Jim Moynihan,
He'll be here.
Michael Williams,
Here.
John Janone, and Wally Gilliam.
All right.
We don't have a quorum, but we're moving on. A lot to do.
All right.
I need approval of the minutes for January 15th, 2025.
So move.
You second it? All in favor?
Aye.
All opposed? All right, they're approved. Approval of the agenda. Need approval of the agenda. I'll second it. All in favor?
Aye.
All opposed? Okay. So we don't have any public to speak, so we'll move past that. Report of the chairman, I don't really have anything other than what we're gonna speak about tonight, which is about footers and grounding, for grounds and different things, so. The old business was, if you remember what the old business, that's where
Shipping
they.
containers, I think, maybe, Roger?
What was it?
Shipping
Yeah.
containers, I think.
Yeah, we talked about shipping containers and I guess that's been, have y'all submitted that yet, or?
Yeah, and I think it's in their hands. We haven't heard anything back, but yes, sir.
So that's going to the legislator?
Yes.
And then it comes back to the commission, right?
Yes, sir.
Okay.
Do they typically ask questions when you submit stuff like that before they?
I think they work it out. I'm not sure if they would ask Marshall for any direction on things. I'm not sure. It'd be the first time I've seen that, so I wouldn't know to speak to that.
And I think they talked about the 911 addressing thing also, and I believe it went out in the tax records, and they talked about maybe in tag renewal. Of course, I get all that email now. So I guess we'll move on to the new business, which we want to talk about a little bit about monolithic concrete footers and slabs. Terry, you just want to take the floor on that?
Certainly. Back when I first started in 2015, we were just starting the 2015 codes. We had just went from 2006 to 2015, and that's when I started. That's when I got my state license. And this presentation just talks about a few things we look for when we go out and look at slabs and footings for crawl space houses as well. This was handed to me back in 2015. Actually, it's a good guide. It's a good, useful guide to look at when you're looking at a slab footing for a foundation. It tells basically all you need to know, except that whenever this was drawn, we didn't have grade stops. They weren't required, and they are now. to help, especially in real hot weather or real cold weather, to go ahead and have the level done on the slab prior to the concrete truck getting there. They used to shoot it as they poured.
Hmm.
And now every 6 foot, they'll put in grade stops, and they can use those as a guide. But item number 1 there is the rebar splices lap at least 16 inches and tied. Bulkheads need to be 16. Number 2, bulkheads need to be 16. Below the steps and back behind the steps, they need to be 16 as well. Back behind the steps, you gotta have a 16-inch space. Used to be 8, I think. 3, the rebar needs to be tied to all the chairs and splices, of course. Top of the footing must be level, and any loose dirt must be removed from the bottom. And the footing must have 12 inches below the finished grade. That's on all footings. That's slab footings, that's crawl footings. It's understood in a code book, no matter what, you've got to get to the frost line with your depth.
That's also for posts on decks and stuff as well, right?
Yes,
12
it
inches.
is. Yes, it is.
Is there a minimum requirement on the size of that pillar for that?
It is. It's in the code book.
Okay.
Under the deck section, there's a table, depending on the diameter of the post.
Mhm.
It goes up, you gotta have about 6 inches around the post.
So a 6 by 6 would be about 12 by 12.
Yeah, yeah.
Okay.
And, rebar chairs spaced no more than 6 foot apart. And that's what I gave Eduardo when he first started, it's take it with you. It's a little checklist. You see your natural slope of the site there. That's about what you see. And just a nice flat footing, everything tied together. All your rebar turned on the corners. None of the tic-tac-toe on the corners.
You want that solid.
It's gotta be continuous.
Solid bar.
Nowadays, with all of the offsets in houses, they're in, they're out, they're sticking out. I'll probably allow one like that on the inside of an offset where they start and finish. But everything else has got to be continuous.
So you'd rather have your joint in the straight sections here and no joints in that?
Yeah, and if they put it together like this right here, they just gotta take a turn 16 inches each way. Cut and turn their rebar. Here's a typical slab. It's got a lot of good information on it. I've got this in my bag when I take it out. When I see a slab that's not deep enough or something like that, you see where over to the left right there. Let's see. Whoops.
You jumped on you, did
Yeah. Right there, you got your minimum depth. You've got your rebar. You've got 12-inch minimum here. You've got your vapor barrier. You've got compacted gravel. You can't have too big a gravel. It's got to be 2 inches maximum. You got to have at least 4 inches of thick gravel.
So this is actually a monolithic,
It is.
the way it turns down.
Yeah. And you've got a little form there. You gotta have 6 inches here. So you gotta have 18 between here and the top of the slab. I'm not real sure about the 3.5 here. Our code book says 4. And you've gotta have welded wire mesh, and I inserted or steel fiber here with a batch ticket showing that you got
The mesh in your concrete.
yeah, you got the compressive strength of the concrete and the mesh in the recipe. They email that to our office when the concrete truck gets done, and we put it in the permit.
Normally on your commercial jobs, you'll have samples. They'll take samples to make sure too, right, with full cylinders. They don't do that on residential, do they? To see the PSI.
We've just got to have it noted on the batch ticket, what the recipe is.
I've watched them pour concrete, and sometimes they'll make a hook where they're pulling that fence up.
Yeah.
I think it would be better to have your, not a stool, but if you drop the ground rod down, you can tie it. I mean, a piece of
Marshall makes them put all that on chairs.
Well, yeah, but that's, yeah, even the chairs would be all right.
I usually have them start out with chairs. If half the slab, if it's a basement, half the big basement bigger than this room, if half the basement's on chairs, I'll pass it, because they gotta get the truck in there,
Yeah.
and they'll just squish it all.
Or have to pump it. They do all chairs.
More and more, you're seeing pumps all the time on everything. Not very many times do you not see a pump on site. The seal plate right there's gotta be pressure treated.
Mhm.
Those anchor bolts have to be within 6 inches of corners and splices. No, 3 to 12 on corners and splices, and 6 foot apart maximum.
So that's, y'all requiring that on residential too, right?
Yeah, and they do more than that, actually. But not many times do I see a 6 foot apart on any anchor bolts. They crowd them in there pretty good. They must get paid by the anchor bolt.
Well, when I poured my slab, I had a bunch of anchors from pole, where I set poles, and I mean, they're 3/4 anchors.
Yeah,
I got a bunch of them on mine.
yeah. They gotta be half to coat.
Mm-hmm.
But, that's your slab details. Here's what we look for if we're out in the field. Now, I've got the first 2 items takes place before they cover up everything. Before they put plastic on it and before they cover up the plumbing. Now just imagine no plastic, no woven wire, and the plumbing's exposed. You've got a standpipe full of water right there. You shake it, water comes out the top, you know you don't have any leaks. The DWV drop is an 1/8 of an inch per foot minimum. The bigger the pipe, the more you'll have on a drop. So as a small pipe, you don't really need a whole lot of drop.
What's that an acronym for, Terry?
Oh,
DWV?
I'm sorry.
No, it's okay.
Drain waste vent.
Okay.
Which would be this one right here,
Yeah,
and then this is electrical here.
yeah,
Somebody turned up some 90s or something.
yeah. I don't fully understand why we don't put air, they don't have to put air on supply lines at this point, but they don't. And it has come up a couple times where they've had leaks.
Are you requiring Rubitex or some kind of coating on all the copper in the slab?
There ain't no coppers and no slabs anymore.
It's all PEX now, yeah.
Yeah. Yeah, it's all,
They used to do it without anything on it, and that concrete eats it up.
yeah.
The pH in that concrete. feeds
I had a
it up.
slab done and I had plumb, insulation wrap on all my pegs. I just feel like better, but it's not required.
So y'all don't see any copper no more in commercial,
None,
they
zero.
still.
The only copper I see is a shower head, or it might hook up to a water heater. That's it, no copper out there at all. It's all pegs. And it's not even the colored pegs anymore, it seems like it's all clear. Used to be blue and red.
Yeah.
Hot and cold. You still see that, but not nearly. They just got one big old truck, a roll of pegs on the truck, that's it. Right there you see the minimum 6 inches above grade for the form there. I believe that's probably a 2x8. That gets you your clearance, that gives you your 16 inches from grade to the top of the slab, 6 inches. The next one down there, you can see they're down there good, 12 inches below undisturbed soil, and 2 rows of rebar number 4. And it's gotta be turned and all that, just like the, we were really, back in the early days, we were really failing these slabs where they'd have to just go in and tear it all down and redo it all, and now you rarely see it. I'm kind of glad of that, because people are getting a lot better product, you know, like this right here. And then you got your wire reinforcement and your 10 mil vapor barrier. That changed in 21, it used to be 6. It's pretty thick plastic.
You take clear or black, it don't matter, do y'all require the pest control, do they spray your slabs?
We don't require it.
Required. Some of your bigger jobs,
Yeah,
especially restaurants,
yeah.
they just, I guess it's the architect or engineer wants it.
The only time I need anything around termites is we gotta have the termite barrier under the steel plate and on top of the piers for a cross brace. If they forget that under the piers or on the piers, they gotta give me a termite letter.
What are they using then?
It's black plastic.
Black plastic,
Every now and then you'll see the aluminum roll.
or the foam?
Coil.
Some kind of foam?
You see a lot of foam on slabs. Yeah, because it don't show itself.
Right.
And it's sitting high on top of the slab. Talk a little bit about insulating the slabs, which is required. I don't know where this picture came from, but I would probably fail that because of that gap right there in the corner. But it's got R10 all the way around. That's gonna give you a good warm slab right there. And you do have, you know, the portion between the foam and the top of the slab that don't have any insulation. But typically slabs are warm in the wintertime, cool in the summer.
So what would you make him do? Could he spray that or just add a piece in there?
He could add a piece, or I wouldn't tell him how to do it. I just tell him it's gotta be
You
fixed.
gotta foam, you gotta fix it.
Yeah, when they say, well, how do I do that? How do I fix it?
Look in your code book.
Yeah, I say, well, I can't tell you how to fix it, but I just know it's gotta be fixed. There's the R10 lying flat on a slab. If this were a monolithic slab, they lie flat right on the inside of the footing, which that's a little bit more of a gap between the exterior wall and the floor. This is one I did just a couple days ago.
What is this? What is that building?
It's a house.
It is a house.
Yeah, little small house. Yeah. You can see he's got his plumbing setting up there. But we were seeing a lot of that too, where they weren't insulated. Where they would just throw up a
So
hole.
he's run out right here with foam, man,
Yeah,
all the way around it.
yeah,
That's what you're talking about.
yeah. That's all the way around. And it holds up on the concrete, I guess. I mean, you can stomp on it and it don't give.
We did a remodel on Hard Rock, and they had built this floor up on the first floor to meet a certain height. There was 3 foot of foam on it, and they poured concrete over it and held up from
Yeah,
day one.
yeah.
It was that thick, it was 3 foot foam, big old like bricks of it, and they set it, and they put the plastic and the wire over it and poured it, and then they busted it up to get that floor down to the main level. And they pulled that stuff out for days.
All of this product that they come out with like that, they go to a lot of they go through a lot of testing, you know, over and over and over, for fire, for stuff like what you're talking about,
To build it up.
yeah, build it up, electrical stuff, plumbing stuff, things like fall protection devices on windows, all of that's got to have listing on it. I think that's it for me, Roger.
Okay. So since we're on the footers,
Yeah,
there was
I would sure like to get some education on how you ground a slab.
it's interesting on, I've always heard it's a euphor ground, and I knew it was a footer ground, but I didn't know why. And then I heard some comments after the fact that they had one footer bust because the lightning hit it. The lightning hit the ground rod that was the euphor ground, and it busted the concrete. So there was a lot of moisture in there for it to do that. That's what caused it.
In the concrete.
In the concrete and in the footer. The footer was holding water too. It wasn't draining right, so it was holding water. So that's what blew it up. So you're looking for pH, you're looking for moisture. So this euphor ground, back World War II, there was a guy named, you're gonna like this, Herbert G. Euphor. And that's where the euphor ground came from. And he was out in Arizona, and it was these bombs where they kept their bombs in this building, a bomb shelter. And they didn't want lightning hitting it because that was it. I mean, it'd take out the whole camp. So they had him go in there and ground this building. And he couldn't get a good ground because there's no moisture in that ground in Arizona where they were.
Oh, yeah.
He drove hundreds of ground rods just to get enough potential for this lightning. If it did hit it, it would go to those ground rods. And that's kind of how he came up with the euphor ground. But what he found out was, on the second bomb shelter, he started testing. And what he did is he took a ground rod and encased it in concrete. And the concrete holds just enough moisture, and the pH is higher in concrete than in the ground, because it holds that pH in there. And that's what you're looking for, is that impedance to be as high as you can get it, or to a certain point. You don't want it too wet, but you get enough of that in there where you get enough ohms so that lightning, because electricity and lightning is looking for the path of least resistance. So a light bulb is resistance. Anything that's got a resistor in it is what we call resistance. A motor has a winding. So it don't have to go through that. So it's looking for the quickest path. I call it the devil, because that's how Satan works. He wants the path of least resistance. So he looks for our weak points to flow, or try to flow. And electricity is very similar. So this euphor ground, and I've seen so much, as I was telling you a while ago, there's so many changes to it. When they first started doing it, they would take a copper, and the power companies do this on their primary. They'd take a copper and skin it down where it's raw, bare copper. And they'd run 20 or 30 feet down and let it just go in and out that your rebar, never tying it to it, and then they'd come up to the main or whatever, so that you can bond your main electrical circuit. Well, they found out that the copper, the pH in that concrete was eating the copper up.
They didn't like it.
So it was going away. So it would eventually just eat it in half, it's gone. So they were losing that euphor ground. So going back to Herbert Euphor's studies, they found that the steel, they even used the copper clad ground rods for a while. That was mandated. They got away from that because it was eating that outer coating. So they went to the steel, and you've seen the galvanized steel ground rods. And what they do, a building I just did in Gallatin they just took that ground rod and tied it to all the rebar, because it's all bonded together, and stuck it up above the concrete inside an inside wall where I could tie my 3/0 conductor copper to that. Now I can use copper above ground or out of the concrete because it's not gonna eat it up.
Right.
It'll make it. And it's a better conductor of aluminum, because you have to pretty much double the size, almost double your size
For
between
aluminum?
copper and aluminum. It's like 1 point something% you have to go up. So I always use a copper on my grounds, whether my service feeders are aluminum or not. I try to use copper on the ground because it's the better conductor. And a ground is just as important as anything else on that building, because it's gonna keep it's gonna keep that electricity from flowing where it don't need to go.
So with that footing that blew up, that got blown up, it was too wet.
Yeah, lightning hit it, and it was, there was too much moisture in that footer. And we have that in Tennessee and Seattle and different places like that, where Arizona you don't. So he found that, when he found the pH level in that concrete, that's what gave him the good ground. So he got away from 100 ground rods. He's only had to drive one, but put it in that concrete, encased. So that was pretty interesting to me to see that. So I guess the requirements are now, and this is what I would want to see if I was an inspector or if I had anything to do with it. I'd want what I was telling you. So let's just say you got your footer dug. They got their 2 rounds of rebar. Commercial buildings, it's a little different sometimes, because the engineer, structural engineer, he'll add a lot in there because of the weight and the load on that building, especially multi-story. So you'll have a whole lot more chairs and or crossbars in there. So I try to drive a ground rod in the corner, inside corner of a chair and a cross tie, and then your bar's running down. I'll drive beside it, leave it up, and I'll take what's called a split bolt, which is brass. And I'll take that brass split bolt and I'll tie all that together. Then I'll take another one where I know my wall is. I'll use their batterboard strings to where I know I'm in that wall. And I'll take another one and tie it to the ground, to the rebar, and stick it up through the finished slab where it's gonna be, and try to hit an outside wall close to my service. And or try to get it below my service if they're still there, to where I can just tie right onto my ground bar. And that bonds everything together. So one of the questions that's been on a lot of forums back in the day was, when you've got a main service, a main electrical service, you want to bond your neutral with your ground. So all your grounds, so I've got 2 ground rods, so Gallatin Electric, 2 ground rods 6 foot apart, 3/0 wire running from those to my neutral bar. My neutral bar is bonded to my can. So everything metal in there is bonded through that bond screw or a bonding strap. It's called a bonding jumper. So when I leave that main panel and I go to a sub panel, I have to pull an extra ground, and they want to isolate that ground from that neutral in that panel. And I knew why, but a lot of people didn't understand why. So let's just say that I've got a 100 amp service, a 100 amp sub-fed panel off of this main panel. And I've got number 2 copper on my 2 hots or 3 hots, depending on the phase. Same size neutral. I can reduce that grounding. So you got a grounded conductor, which is your neutral, and a grounding conductor, which is your bond that ties all your metal together, that bonds all your metals to your UFR ground and everywhere else. If I bond those in that panel, and you put an amp probe on that neutral, on that ground, it's taking half of the current on that little wire. You see what I'm saying? So if you got 2, in other words, you got 2 neutrals, you don't have a ground and a neutral. So when you amp the neutral takes the unbalanced load of that panel to ground. So if I've got, it's not total this, but this will give you an idea. So I've got 20 amps on this leg, and I got 10 amps on this leg, say it's single phase. The unbalanced load is 10 amps. somewhere close to that. So that's the amperage on that neutral. So if you amp that neutral, it's gonna show 10 amps on it.
It's gonna take
Okay,
it.
because that's where it's taking that unbalanced load to ground. If you put an amp probe on that neutral, and they're tied together in that sub panel, you're gonna have 5 amps on that, and you're gonna have 5 amps on that ground. Well, that ground is not sized big enough to handle the 100 amp load on that unbalanced load of that neutral. So we'll end up burning that ground up, and then you get between that ground, it's not a good day for you. It's gonna hurt you.
Mm.
So that's the reason they isolate that ground and that grounding conductor and that grounded conductor, the neutral and the ground. They wanna isolate that, so it's not carrying no load, it's just taking anything that's foreign that's not supposed to be there, just like on a ground fault breaker. That ground fault's looking for something between the neutral and the ground touching. It ain't looking to see if that hot's wrong. It's looking at that neutral. So if that neutral gets broke, or it's touching the ground somewhere, which you would be the ground, it's gonna kick it. Because you become that load. When you get between that, you become the load. Well, that ground fault recognizes that ground's not right, and it kicks it, and that's what saves you. So that's what it does. That's what it's about.
They don't have anything to do with power up, it's that power side.
It's always a path. Wherever it goes, it's gotta come back. And when it comes back and it gets broke, if you get between it. So here's an example. I'm hooking a water heater up, and I thought, well, I'll hook everything else up hot. I'll just hook this up hot. Not thinking. Being stupid to start with. Should have had it turned off. Don't ever work nothing hot. Even as an electrician, I'll tell you. And I do it all the time. So I hooked one side of that water heater up. Of course, the water was cold, so it's gonna start heating. And I grabbed the load side coming off that water heater, and that sucker ate me up. I mean, it ate me up. My teeth were rattling. Because I became that path.
Yeah.
It wasn't just it was the amps and everything getting me. It wasn't just the voltage. I became the path. And when you become the path, it hurts. Now, the next time I got hit, I was still young, and I was making a meter base up on the bottom. Top was hot. I'm putting new wires on the bottom of the meter base. And I could not get that dang 3/0 to bend in there. And I did like that and hit them 2 top lugs. Like that.
That was all of it
Oh,
too.
that shook me, boy.
Mm.
I said a bad word. Dadgummit, that hurts. I said. So anyway, the grounding is very,
So-
very important.
How do we make sure these slabs are grounded properly? I mean, that all takes place, it ain't in our code book.
Do y'all, well, when you go look at the footer, there needs to be a for ground, some type of ground. And I don't like copper. I don't really want copper. Now, I know that, one of the inspectors, he'll allow them to take a piece of rebar and stick it up, even out of the footer. Like let's say you got a brick ledge,
Yeah.
he'll have to pull it past that brick ledge and turn it up where they can connect a ground wire to that. I do know that. That's something that really needs to be addressed, because I guarantee you, 90% of what you're going out there to look at does not
Right.
have that footer ground.
Nope.
And that's because that's the best ground you're gonna get, especially in the
Yeah,
concrete.
we talked a lot about grounds when I first started, and there's nothing in the residential code saying we need to worry about grounds anywhere.
I know Steve Barnes requires that rebar.
Yeah,
I don't even like rebar. I want it to be a ground rod, because it's a 5/8 or a
that's
half
all I
inch.
see is rebar.
Yeah.
And it ain't hard to figure out where your service is gonna go.
No.
So all you gotta do is have your builder, or most of the time when you're pouring a footer, they don't know who the electrician is unless they use them all the time. But they can take that ground rod and go like this and bend it up right there at the house where they can attach onto it.
Start asking for that.
Yeah, I would definitely start at, and put it on your permit application. U for ground is required. Cause it is, it really is. by
How's that
code.
spelled, Rod?
UFER. I'm gonna leave y'all this paper. Y'all
Marshall says to make sure make sure that you cover you for ground, because Roger's gonna be there, he's gonna wanna know what we're doing right there. What's a you for ground?
It came from that guy from World War II. He's the one that they named it after him.
That's good information.
And it's probably the best ground you're gonna get. Being in that concrete and everything, as long as it's steel, not copper. So if it was me, I would put it on your permit application.
Yeah.
Make sure they see that line item in inspection. I know it adds an inspection to y'all, but you could have,
Well, we're working on our staff right now
yeah,
to where we can cover another inspection or two. And we're almost there. I was hoping Eduardo could come. He's our newest licensed inspector. He's excellent inspector for no longer than he's been doing it. All the builders like him. For the most part, you know, he's pretty tough on them. But he's a good fellow. Learns very smart. Speaks 3 languages. That comes in handy nowadays when you're out on jobs and stuff, or even people that come in and try to get an application, try to get a building permit. Sometimes he has to run interference for the girls up front. But if you're ever in the building early or late, stop in and say hi to him. He's a good fellow.
well, is everybody okay with an adjournment of the meeting?
Yep.
I move we adjourn.
All right. We're adjourned.
It's good seeing
If
y'all.
y'all stop that, I'm
Yeah.
gonna tell you. You'll turn it off.
Okay.
So